Hello, I'm Dr. LALITHA ESWARAN, AP Chemistry, Trinity College for Women, Namakkal. I'm going to explain about isopoly and heteropoly acids. The polymerization of simple monomeric oxide ions of chromium, molybdenum, tungsten, etc. occurs when their alkaline solutions are gradually acidified. If from any oxyacid the oxygen atoms are replaced by the radicals of the same acid, the resulting compounds are termed as polyacids. They can also be defined as compounds derived from simple acid by the elimination of water between two or more molecules of the acid. The reactions are given below. The acids which are obtained as a result of the apparent condensation of number of simple oxygen containing acid molecules to give compounds containing more than a single molecule of acid anhydride is called polyacid. A familiar example is the reaction of chromate solution, which is yellow, with excess acid to form dichromate, which is orange in color. The polyacids can be divided into two groups: isopoly acids, where the acids which condense together are all of the same type, that is MOO6 groups or all WO6 groups. Heteropoly acids, when two or more different types of anions condense together, that is molybdate or tungstate groups with phosphate, silicate or borate groups. Isopolychromate. The oxide of chromium is strongly acidic and dissolved in aqueous sodium hydroxide, forming discrete tetrahedral chromate CRO. They exist both in solutions and as solids. Chromates are stable only at high pH. The basic unit of isopolychromate is CRO tetrahedra. The structure of chromate, dichromate anions are given in this slide. Isopoly molybdate. When the trioxide of molybdate is dissolved in aqueous alkali, the resulting solution contains tetrahedral MOO4 2- ion. If these solutions are made strongly acidic, precipitates of yellow molybdic acidic MOO3 2H2O is obtained, which convert into monohydrate if warmed. At pH between these two extremes, polymeric anions made up of MOO6 octahedra are formed and their salts can be crystallized. The reaction is given here. The ion present in the molybdate solution at a pH of about 10 is simple MOO4 2-, but if the pH is lowered to about 6 to 8, polyanion formation commences. The reaction is given below. The structure of isomolybdates is given in this slide. Isopolytungstate. The formation of isopolytungstate is similar to that of molybdates, but its chemistry is even more difficult. The three types of polytungstates: normal tungstates, paratungstates and metatungstates. Now, normal tungstates have a general formula M times WO4 N times. Preparation is by dissolving tungsten trioxide in sodium hydroxide and crystallizing the solution. The simple tungstate WO4 2- exists in strongly basic solution. Acidification results in the formation of polymers built up of WO6 octahedra. The nature of tungsten species formed depends on the pH. Upon acidification, paratungstate and metatungstates are formed. The reactions is given here. The structure of tungstate is given in this slide. Isopolyvinylate. In strongly alkaline solution, the ion present is VO or VOOH. As the pH is reduced from 13 to 8, condensation to VO takes place. Further reduction pH to 7.2 gives the so-called metavanadate. In the solid metavanadate, the anion consists of chains of VO tetrahedra linked by sharing corners at the species in the solution is almost a trimer or tetramer. As the pH is still reduced, further orange decavanadate is produced at about pH 6, VOO10 6 minus ion. The ion is protonated as the pH is still lower to 3.5. Many salts of decavanadate ions, for example Ca3V10O28, occur as minerals. In very acid solution at a pH 2, VOO2 plus ions are formed and finally hydrated to V2O5 separates out. The structure of isopolyvanadate is given in this slide. I'll be showing about heteropoly acids in another video. Thank you for watching this video.